We're in Algebra 2, 9.6a. This is the standard form for quadratic functions. We have 11 previous videos that if you become lost, you can just click on the description and figure out where it got confusing. For a quadratic function described by the function of x equals ax squared plus bx plus c, where that a doesn't equal a 0, we can complete the square and rewrite it as the function of x equals a times the square of x minus h plus k. It becomes a quadratic function in standard form. That's what this second one is. It's a quadratic function in standard form. And we should recognize the difference between the standard form of a quadratic function and the standard form of a quadratic equation. Okay? So here's the standard form of a quadratic function. That's the standard form of a quadratic equation. We've seen that before. We did that, didn't we? Now, we're going to do function. We can find the standard form for the function of x equals x squared minus 6x plus 4. What we do is we complete the square inside the parentheses and we take half of the x coefficient, this blue 6. So half of that 6 would be a 3, wouldn't it? And we square it to get a 9. 6 times half equals 3. We square it, we get a 9. Now what we do is we add a 9 minus 9 inside the parentheses. And because 9 minus 9 equals 0, we haven't changed the value of the expression inside the parentheses. It's just like we're adding a 0, isn't it? We can use the associative property for addition, and we can regroup it. So instead of having this, we cut it off right here after this 9, and we add a negative 9 plus 4. When it's factored and simplified, that negative 9 plus 4 is going to be a negative 5, isn't it? And on this side, we can do 1 times x minus 3 squared. See? We could do 1 times the square of x minus 3 for this one. Now we can find the vertex. We did this in the last video. We've got a 3 and a negative 5 for the vertex. We can find the line of symmetry. We do x minus 3, set it to equal 0, add 3 to each side to solve for x, and we get x equals 3. That's going to be our line of symmetry. We can find if there's maximum or minimum values. The minimum value is going to be at 3, negative 5, because 1 is greater than 0, the graph is going to open upwards. And our minimum value is a negative 5. That's right there. That's our k value. See? Let's try this again. We can find the standard form for this function. The first thing we're going to do is we're going to factor this part of the expression right here. We're not going to pay any attention to the minus 7 right now. So we're going to factor the negative 2 from the first two terms. That's going to make the coefficient of x squared inside the parentheses a 1. See how we did that? We just put parentheses and split it away from that 2x, from that 2, that negative 2, I'm sorry. So we just put parentheses here and here. We take half of the x coefficient, we take half of this 5, which is going to be 5 over 2, isn't it? And we square it to get 25 over 4. Now we're going to add 25 fourths minus 25 fourths inside the parentheses, just like we did over here when we did the 9 minus 9. We're going to split it apart using that associative property for addition and regrouping it. So now we have plus 25 fourths plus we're going to have 2 times 25 fourths minus 7, multiplying by the negative 2 and then using the distributive property and rearranging the terms. And we factor and simplify. This is going to give us a 50 over 4, isn't it? And we can rewrite this as 28 over 4. And when we subtract them, we get 22 over 4, which is 11 halves. See? That's how I got that for our k value. So now we can find the vertex. We've got 5 halves and 11 halves. That's the point where the vertex is. Our line of symmetry is going to be this x minus 5 halves, so setting it to equal 0 and solving it for x, we get x equals 5 halves. Is there a minimum or maximum value? Yeah, a maximum at the 5 halves and 11 halves at that point. And this negative 2 is less than 0, so our graph is going to open downward. And our maximum value is going to be at 11 halves. So on the graph, that is going to be the highest point for our downward opening parabola. See? All right? So if you haven't seen the previous video, it would really, really help you to watch that one, okay? That link is in this description. Now our next video is 9.6b, and we're going to talk about quadratic functions and those maximum and minimum values. I'm going to add this video to the Algebra 2 playlist. I'm going to have a link to Chapter 12 and 13 from last year from Algebra 1. That could help you. 12.4 talks about graphing functions, and Chapter 13 is all about quadratic equations. And I'm going to have links to those previous 11 videos that we've done so far for Chapter 9. And if you don't remember completing the square, that was in 8.1b, and I'll have a link to that one too, all right? So I know it's been a while. You may have forgotten how to do it, all right? Or you may still remember, which is great. I hope you're having a great day, and I will see you next video. Keep trying. Bye.